Good morning, good afternoon, and welcome, ladies and gents. My name is Wayne Burke. It gives me great pleasure to be bringing you practical AI for IoT Stage 1. We're going to be looking at helping you build foundations so you can take your AI, your artificial intelligence, to the next level. We're going to be warming up with a little bit of, first of all, an example of AI in use, where this is a presentation years ago from Nicholas Negroponte, who is one of the four founders of the MIT Media Lab. And this was the original TED Talks presentation. But what we want to highlight here is kids that were given a tablet in Ethiopia. No schools, no teachers, just give them the device and let them figure it out. So, learning when there are no schools. And this is again just a key point when we start looking at how we learn. We have to understand artificial intelligence because we're going to have to use machine learning and we're going to have to build our AI intelligence. And that requires machine learning. So a few minutes of warming up with watching these kids learn how to hack Android without a single teacher, without school. They were given the device. So we want to just welcome you all here today. You are all welcome to learn openly. We don't want to force you to learn any right or wrong way. You're going to be learning the most effective way that you find most effective. And that's generally, everybody learns the most effective way by experiencing what it is they've got to learn, as you're going to see today.
With no instructions and let the children figure it out.
Now we can see where these kids live. They don't have beautiful hot running water. They're not very rich or wealthy. So this is without any background. So no matter what your background is, if you want to get into AI, IoT, you can all do this. Doesn't matter what your background is, but watch this child learning how to use technology without a teacher. This is a very, very good example of machine learning. We are, hypothetically speaking, I'm sure, very powerful machines, but we have electricity running through us. So we call this machine learning in the AI world.
And in a short period of time, they not only turned them on and were using 50 apps per child within 5 days, they were singing ABC songs within 2 weeks, but they hacked Android within 6 months. And so that seemed sufficiently interesting. This is perhaps the best picture I have. Kid on your right is sort of nominated himself as teacher. Look at the kid on the left, and so on. There are no adults involved in this at all. So I said, well, can we do this at a larger scale? And what is it that...
All right, so that was a nice quick warm-up for what AI potentially could be. And as we now break into a little bit of how AI can help save our humanity, this is the part where we're going to be talking about technology, and we're going to be able to talk about technology in a way that we're going to teach you what to do with it, or at least the initial foundation to set it up so you can be, off to a great start learning AI and machine learning. But let's get straight into it, ladies and gents. We're going to be looking at some interesting topics today. First of all, just a quick broad background about myself. Been in the industry for a long time and been doing things from the late 1990s. And if you've been along the road that's been traveled by many, you start recognizing things. So uncertainty is the only certainty there is. And knowing how to live with insecurity is the only security. Very famous statement from John Allen Paulos. You can read more about this. You can go and Google more online. I want to, of course, share a lot of my knowledge that I've been gaining over the long time in technology. I wanted to make sure I give back and share this knowledge with people that want to get into technology, because we are short of skilled professionals in cyber, in IT, in AI. So we're going to look at IoT foundations today, AI. We'll discuss hardware and software for what we're going to be setting up today. We're going to be looking at setting up everything from a ESP8266 IoT chip. It's got 160 megahertz CPU and as small as 1 megabyte of RAM. You get them a bit smaller, but really 1 megabyte up to much higher amounts. Not that much, but you're going to see how much we can do with a small, cheap ESP8266 chip, an IoT embedded computer. And then we're going to be looking at the foundations of AI, your artificial intelligence, where we'll be looking at using a Raspberry Pi and Intel Neural Compute Stick, Movidius. So these are just some of the basics of being able to set that up, but we'll be showing you how to set up the foundations of your OS, Arduino, for your software, and then how we can actually set up some of the hardware devices in preparation for learning. And so we're going to start off with IoT, because IoT is pretty much everywhere, right? So the Internet of Things refers to a network of physical objects. Now these physical objects can be all sorts of different types and shapes and weird looking devices that do all sorts of things, not just for, technology or for fitness, or because we got a lot of fitness trackers, we got a lot of devices that are coming out to help augment and manage your physical exercises, as an example, or what food you eat in, and all sorts of sensors. But we're going to have these all over the place in motor vehicles, in appliances, in street lights, you name it, because it's embedded with a sensor, software, and perhaps other technologies that can be used for exchanging, communicating with other types of devices on the internet or over the internet. So the technical aspects of IoT include a huge plethora of sensors and devices. You're going to have, a sensor for everything from humidity to heat to lasers, tracking, for machine manufacturing, and then connectivity. Most of those all need to be able to communicate through some form of a network, whether it be cellular, satellite, Wi-Fi, Bluetooth. And then the data processing tends to all tie back into the cloud. So this is really where you'll see there's going to be many different interfaces, like the user interface. And those devices can be very, very sophisticated nowadays, because you're going to see what we can do with a very small device. So we're going to be starting off with an ESP8266. So before we get into that, let's go and just look at a quick ESP8266 wiki. We just want to go to get the general details about this specific Internet of Things device. So it's a low-cost Wi-Fi microchip. It's got built-in TCP/IP networking software. Now what we're going to be doing is we're going to be setting up the software and the hardware, and we're going to be looking to flash this. Now the one chip I have is this exact board over here with 1 megabyte of memory, and it's a SoC, it's a system on chip. Right, so we're not talking about your socks that you put underneath your shoes. Hopefully we're talking about your system on chip. And you can see some of the basic features. It's a 32-bit microcontroller, and it has a total of 160 megahertz core, which is actually 2 cores effectively, and as little as 1 megabyte of RAM. And you can dive much deeper into the inner workings, so you can see the circuitry, and you can actually see a die shot, so you can actually see through the electronics. So you'll have access to the memory and the size, and there's various different form factors that are, for the most part, all FCC approved. Right, so this is the initial, just the hardware chip we're going to be looking at. So it is a microprocessor. It's got, in the 2 devices I'm going to be using today, one will be one with 1 megabyte of memory, And you're going to be shocked to know that we're going to be able to set up a project that will allow you to do Wi-Fi de-authoring. Of course, you need to be able to do this in an area where you have access to the network devices that you own. You can't just go and run a de-author in any network, because that could be potentially legal in a lot of countries. So whilst we're going to be showing you how you can actually build this little device, it does have some pros and cons to obviously using the device. So you can actually use it for multiple purposes. So there's just some of the basic information. I'll put that in the chat. And we will have 15 minutes after 60 minutes of hands-on. So we will break it out into a Q&A session where you folks will be able to ask all sorts of questions that you feel free to ask. So yes, this is the one device. And so we need to set up some of the software and the hardware. Well, one of the projects we're going to be building is this project called ESP8260. It's a de-author device, and you can see they've got a version 2 and a version 3, and each of those have different capabilities. With version 2, it makes it a little bit easier. For the most part, it's got a web interface, and so that's going to make it a lot easier to actually use. Both of the versions have the same basic functionality. They're able to de-auth, send out beacon and probe management Wi-Fi frames, and communicate over the serial command line. You can also scan your local network for access points and clients, and this is an open source project. So you'll see they've got great instructions on the do-it-yourself section. And if you go to their GitHub site, we will be able to access all the resources we need. Now, we're not just going to download the firmware and flash the device, because downloading somebody's firmware and flashing the device is pretty straightforward, but we want to get you to be able to use the tools that will allow you to modify the code. So in order to learn about AI and IoT, you pretty much, as a necessity, have to learn to code. Now, coding is not that difficult, especially when you've got hardware devices where you're going to be building a project by doing something. You're not just messing around with some device. You're going to be building different devices to do a specific set of functions. And so the de-author has been around for a long time. Fortunately, we do have defenses against this. So some of the newer wireless devices will not allow you to de-auth them, kick them essentially off the network. And the idea behind this is they would then capture a hash when you then reconnect to the network. So as I mentioned, this is the first session. Each session we're going to be building upon this foundation. So we're bringing you a toolkit of open source hardware and software, and then we're going to be building a large array of different projects. So my area of specialization nowadays is building artificially intelligent network decoys, honeypots, defending drones, both offense and defense. And for that, we need a lot of artificial intelligence. So the drones that can fly themselves practically without actually needing to use a flight operator. And so these are some of the things that we're going to be talking about and teaching for free in the coming sessions. We are just starting this towards the end of 2023, with a whole lot more sessions on a regular basis in 2024. So we want to get you the foundational things. The first thing we want to do is set up our software. And you would have heard, I'm sure, about Arduino. Arduino is originally manufactured in Italy, hence the name Arduino. My Italian's pretty bad, so I'm not even going to try and, I'm going to butcher that if I try. You're going to see there's a huge array of new Arduino devices that are coming out. Just take a look at some of their Black Friday deals. And then they've got various different types of add-on boards that you can actually use. So here you can see 5 ways to visualize your Arduino or ESP sensor data. So whilst we've shown you how to set up a sensor today and some of the fundamentals, your code environment, you can then continue to go and build all sorts of ESP device projects. And they've got tons and tons of various different open source projects. You can go and participate by going to their website. So let's jump straight into some of the hands-on right now, and we're going to go and set this up. This session is being recorded. We will be making it available publicly, so we are to share and we care. So don't worry, we're not going to change you with anything. There's a reason why we're doing these sessions for free, because I personally want to make sure I give back to society and teach people to get the fundamental skills they need without going to spend a lot of money on some of the commercialized types of education. Because what about the people that are not from a wealthy background, right? We want to make sure we're supporting everybody, no matter what your race, color, creed, religion, but whatever but doesn't matter. We're here to help y'all learn. This is just a virtual machine running Raspberry Pi OS. So it's a 32-bit operating system. There's nothing fancy. I'm going to simply go ahead and say sudo apt update. So I've got the latest repository details. I'm not updating anything. This is just updating my index list effectively. And then I'm going to go ahead and download Arduino, the actual software. So if you go down to the software tab, I've already gone ahead and downloaded Arduino, but some of you might be on a Windows machine, some of you might be in the cloud, some of you might be on a Linux machine. So whenever you want to do things like IoT tinkering, prototyping, I would always wholeheartedly suggest using Linux open source. It might be a little bit of a learning curve for some of you folks initially, but it's going to be very well worth it. So you're going to download Arduino. I've downloaded mine for Linux. I'm using the app image, and obviously I downloaded the 64-bit version, but I'm only running a 32-bit version operating system. So that's probably not going to go so well for me, but that's okay. I'll bring up a different virtual appliance. So this is the part when you recognize you need to check your operating system first. So when I go ahead now and say, hey, cat etc OS, this is going to give me my basic details about the software, but nothing too in-depth. So at this point we could also use uname-a, if I could spell that right, uname-a, and there we can see, well, it's saying it's running AMD 64, but it is saying x86 as well. So we're about to find out if our software will run on this operating system. And we've already gone ahead and downloaded it. So when you've downloaded the software, you're going to need to go and enable execution of the application itself. So here's the latest version of Arduino. I'm going to right click on that, and I'm going to click on the properties. And under the permissions, you can see execute nobody. So we could go ahead and say anyone to allow execution of that file. Again, if you missed that, just click on your right click properties, and then onto your permissions. You need to enable the execute. Once we've done that, now we can go and try and double click on that. And it's going to say, hey, well, you want to execute this? Sure, we can execute it. Now I've got to tell you, I installed this operating system some time ago, so I cannot absolutely remember if this will allow me to run Arduino or not. But the way we learn is by trial and error, folks. So you should never ever be afraid to fail. If it doesn't work and you're going like, okay, well, it looked like it was working. I had a previous version there. I wonder if that's working. Executing terminal this time. I chose the other option the first time I tried to run it. And this is not even telling me anything about the application. Of course, I can go and run it from the command line. But as you've just seen, great way we learn. but it's not really going to be very conducive to what we need to do. I could install the other version by just doing an apt install, but obviously as you want to see some of the things we're doing, this is how we learn. We learn by trial and error. So I'm going to go ahead and I'm going to just power off this virtual machine. And some of you may have heard of Kali Linux. Kali Linux is a custom Debian appliance. So it's based on Linux as well. There's just thousands of tools already installed and built in for learning ethical hacking and digital forensics and IoT, and it's a open source Linux operating system. It is definitely built on AMD 64-bit, so this is definitely a 64-bit operating system, and they've actually got some additional features enabled to reduce your threat landscape on the operating system. So they have actually done some sufficient hardening, and I'm going to go ahead and just log in. It's just a simple OS you can download from kali.org, as in KALI.org. And I'm going to go ahead now and start the download of Arduino. Go to the main website, click software, download. And it's always recommended that you give back to these open source community projects if you can afford it. So this is just downloading one image file, and whilst it's downloading that one image file, we're going to go ahead to our ESP8266 De-auther GitHub. And there's a lot of derivatives now as well, forks, no, projects doing the same thing. So this is the official developer of this project. It's a young German guy, and you can see the latest version is 2.6.1. So we want to go ahead and download that version. So we'll click on the download, and we don't want to just download the binary file, because that's like going to defeat the whole objective of us being able to download it and use the source code. So you can click on the source code over there, or you can simply go back to the main code page and just download the code, which will include everything you need as well. So there's multiple ways you can download this, as I've just shown you the first way. Then the second way is I'll download this zip file. It looks like I downloaded already before. And so now I'm going to go and open up my images. So here's the newer version, and I can now right click and click properties, and then go to permissions, and you can see allow this file to run as a program. So we're going to put a tick box there to allow that. Select close, and we're also going to need to extract our source code. Let me just clean this up. I downloaded it twice. So I'm going to say extract here, which will put it in a folder for me. And now I can go ahead and run the Arduino executable. I want to make sure you read the terms of service. So you can go and read the terms of service. If you agree, click agree. That's going to open up your application. So as you've seen, this is the most effective way when we want to learn IoT, Internet of Things. We're getting you to learn this from the ground up, where we're going to be teaching you the tools, the software, the hardware, the project, the awesome, fun topics. This is your very first stage 1 session, getting you to set up your environment, your tools. And then as we go through at least twice every month, we're going to be running these events. So once every 2 weeks, effectively, we'll be running these free workshops. So when you've opened up your Arduino for the first time, you're going like, okay, well, it's still busy downloading different packages and drivers and things like that. which is fine. But now we want to go ahead, so we verified that we have Arduino software that will allow us to do coding and all sorts of things. But as it's busy still downloading packages and drivers and whatnot, I'll minimize that. And I'm going to open up the actual INO file. So this project that we showed you from those young folks right over at GitHub, De-auther, you can see they give you very, very well documented written information. So you can see the password is pwned and De-auther. When you need that, you'll see how we'll connect with it. And so once you've downloaded your code, you're going to go into you need all of the code. You cannot just extract the one file here. You actually need all of the main files, and what we're looking for is a file that has ONI. Oh, sorry, INO. ONI. There it is. So we can now simply go and open up this file by double clicking, and that's just open up like this simple code. But we want to open this up in your Arduino software. So here we can see it should be now finished. It's busy installing some of the other packages still, but I can still now select File, Open, and I'm going to browse to my downloads, and there's that folder I extracted. And I'm going to go into the ESP8266 De-auther folder, and there you will see the ESP8266 De-author.ino file. So the INO is just basically an extension that's going to be identifiable by using Arduino software. So we can now go ahead and say open up the software. It is open up another interface for us, and all of these steps are going to be very, very well documented. Now what you're looking at right now is all of the source code for this entire project. So this way, if you want to learn about IoT, you need to understand how to program it. Everybody thinks programming is difficult. It's not difficult when you have a purpose. You want to program something that you're going to solve a problem with, like maybe it's counting, or something simple that you might realize is easy to do with a computer, or if you have like a calculator. But counting with only 10 fingers and 10 toes could be a little bit challenging when you go into the much higher numbers. So this is the initial part now. We go back to the initial settings. You will actually see the instructions. I think it's under the wiki. And you'll see there is a do-it-yourself tutorial. So this is the exact installation we followed. You can see the installation Arduino IDE. Now we could have just flashed the bin, the binary file, but that's not going to help you really get into the machinery of the software at least, and the hardware at the same time. So we really need to be looking at the mechanics. So if we click on the Arduino IDE, there's even a video tutorial that you can go and follow beyond the fact. And so here you can see these are the main 8 steps that we're going to be using. So at first, I'll just copy that and put that in the chat. So those are the main steps. We've now set up our initial Arduino software, but we haven't set that up for our specific different IoT type boards. So right now we've got this project that we've got access to the source code, but we need to now go and specify the actual board that we're going to want to use this on. So the first part is going to the file and then go to your preferences. And under your preferences, you're going to want to add additional boards manager URL. So what that means is this will point out what board or multiple boards we can use. Again, if you go and look at their project, you can see there's a link there for supported devices. So I'm using two different devices. Today I'll be using the WeMOS D1 Mini, which has 4 megabytes of RAM, and it's easier to flash or program. And I'm also going to be using the board I showed you, the very cheap 1 megabyte of RAM. Alright, so there's a multitude of different supported devices that you can use. And right now we're on step 3. So we're going to go and copy this, to go and add it to our board. So we paste that, we go ahead and say OK. Once we've added that, we can now go to the Tools, Boards, or Board, and you can now see we've got this Board Manager, which we want to go to the Board Manager so we can go and search on the ESP De-auther, so we can go and add that specific board. So ESP 8266, and you should find the De-auther by SpaceHun. Alright, so the latest version there is 2.7.5. We're going to go ahead and install this. So as we are setting this up for the first time, once this has been set up, we will then plug in my board to verify that it is recognized. But as you can see right now, it's still downloading all the packages. We need to also select the board by going to the Tools and Board. So whilst it's busy installing this, I can now still continue. So go to your Tools and then Board next. And well, now you're going like, oh, well, it's not there yet, Wayne. Sure, it's not. It's still busy installing, of course. So you then be able to actually go and select your board. And once you plug in your board, you'll be able to go and specify a port that it's using. And we'll be showing you how to do that in a minute. So whilst that's still busy installing the packages, I'm going to go ahead and open up a command prompt. And I'm going to just plug in my board. This is me using virtualization. So I'm going to say connect this IoT device to my virtual machine. And I'll select my virtual machine. Now that I've selected to connect it through my physical Windows machine to my virtual, I can go ahead and say ls USB. List USB device. And at first you're going to be going like, what the heck? Well, I'm using the 1 meg version, so I'm actually just using a USB carrier board, which is your serial converter board, and it's a Qing Heng Electronics CH340 serial converter. So effectively it's just converting my small little chip. Let me make sure everybody's following. So this is the exact version I'm using right now. It's only 1 megabyte of RAM, and you can see it's got all these pins. So the additional device is just a simple USB carrier board that you take this chip and you plug it into the USB board. It's about $5, a couple of euros on Amazon as an example. So that's one board you can use, or the WeMOS D1 Mini, which won't need a carrier board. It has it all built into the actual board itself. So we're going to go ahead and say DMESG for your daemon message so we can see more details about the board. And what we're looking at right now is it's telling us that it is connected through a UART converter, which is actually attached to your TTY USB 0 port. So you can see the TTY USB 0 port. Alright, so now it looks like everything's been installed. We've installed the actual specific board. So if we go back to our tools and we select the board, now we have the ability to select our ESP8266 board, and what specific version I'm going to select the generic ESP8266 board. So that's the default that I've selected. And if you now go to your tools and then you look at your actual port, you can see why I needed to make sure I knew what port my device was going to be connected to. So you can see it's telling you and me it's connected to the TTY USB 0. It's also telling us that there's a crystal, a quartz crystal, a 26 megahertz quartz crystal. So it can be set up as a Wi-Fi device that can be sending out traffic through wireless networks. So I'm going to select the Dev TTY USB 0 board. And once I've done that, job done. So now at this point, once I've got the main components set up, you can see I've got access to all of the source code. So I can go ahead and change anything I want within this project because I've got access to all of the source code. Alright, pretty straightforward for now. So all I'm going to go ahead and do is to go and test, so to verify that my code will compile, because I can still see it's still indexing on the bottom left there. But it is detected of saying, oh, I am connected on Dev TTY USB 0, it's generic ESP8266 board. And so the indexing is finished, so I can click on the verify now, the top left, the little arrow. So as you go and try and compile your code, if you've got any problems within your code, it will obviously give you an error message, and you'll then be able to try and troubleshoot it based upon whatever error message you got. So again, I'm really making today fundamentally straightforward, so you can see step by step, we're not making things too complex yet, because we want to make sure we can actually have people build and understand the software and the hardware foundational tools that are needed to go and build all sorts of different types of prototypes. So whilst that sketch is compiling, you will see there's a lot of different prototypes that you can go and build with Arduino. And whilst I'm on this topic, today's session we focus on using Arduino and a Raspberry Pi, but on future sessions we're going to be looking at using the microbit IoT device, and this is your British manufactured device. They're pretty cheap, they're about $30, and you can see very similar. What's really helpful with this device is that actually teaching kids how to code couldn't have been easier. So if you folks want to go a little bit deeper, a little bit beyond Arduino perhaps, or depends on how you find it, we can go and use the Let's Code, which means you can use the best of all worlds. We can use the Make Code editor, which will actually allow us to use Python as well, and this will allow you to go and create whatever type of project you like. But at the same time, you can actually see there's tons and tons of tutorials that you can do with your kids, learning the fundamentals of IoT. You can make guitars, a footstep counter, snap the dot, a binary stopwatch, dices, name tags. Oh boy, the list goes on and on and on and on. Pretty awesome. Even micro chat. Pretty cool. Programming your LEDs. And you can see these are just some of the projects that everybody can actually go and build. And so to make it pretty clear, like, we have a huge issue with consuming too much water. The kids are learning how to obviously use the exact amount to water the plants based upon getting some feedback. So they can go and monitor the moisture in the soil, or they can go and check to see if the plant needs watering, if the soil's too dry, as an example. And so whilst you look at this sample, you can see you have to just click on show instructions, and it's going to walk you through everything step by step. The code, the hardware. So if you look at the code, you can actually see you can use the Scratch program, but like drag and drop block programming, or you can use JavaScript, or you can use Python. So if you click on Python, you can get your code converted very quickly to be learning Python or JavaScript. And so here we can see some really fantastic projects that you can participate in as well. Alright, so today we're going to be looking at using Raspberry Pi Zero because we're going to be building Pwnagotchi in a minute. So at this point that was our IoT, and then to actually flash our IoT board, we can now actually go ahead and you can see the little arrow to pointing to the right. If you hover over that, it will tell you, aha, upload. So yes, I want to go ahead and upload this code to the board. It's busy flashing the actual software now. So it's compiled it into a binary file and it's now uploading this to the device. As you can see, it's saying connecting. Now there is a button on the device that if I don't switch it into programming, it's going to keep saying it's trying to connect. So switching it during mid-cycle, well, yeah, there were some errors that it failed because it just wasn't connecting. So if I go back now and I run that again, we should be in better luck. It shouldn't have to recompile the sketch, it should be pretty quick. But I needed to make sure I had my programming enabled. There's a switch on the USB carrier board where you can see now it should connect. This is not always the most reliable way of doing it through a virtual machine, although it does see the board and everything else connected, so there should be no reason why it won't connect, except it looks like there's a slight problem. So timed out waiting for the packet header. Let's go ahead and try the board again. I'll just unplug it and re-plug it in. And as I plug it in, I want to make sure that it is detected. And there it is detected. I can go ahead now and just run that again. And there we can see much better. It's now actually connected and it's busy flashing that board. So pretty straightforward. It actually detected I have 4 megabytes of RAM, and there you have it. So once you've flashed the board, you can power it on, and then you're going to go and connect to the hotspot of this IoT device, and you then can go ahead and launch some of your defense or offense types of attacks. Pretty straightforward. Alright, now we've got about 15 minutes left of the session today. So this was a little bit of your Arduino IoT. So remember, Arduino is an open source electronics platform based on easy to use hardware and software, and it's intended for anyone making interactive projects. It also gives you the ability to connect to the cloud. Our next project is looking at the foundational specifics of artificial intelligence. And this is the part where, and I'm being absolutely honest with you, when people don't like AI, they have opinions about something they've never tried to build. So here's my honest to goodness suggestion. Before you have an opinion of whether AI is good or bad, go and build things with AI that you can see what AI can be used for. Because just like a gun could be used for good purposes or a bad purpose as well. Or a motor vehicle can be used for good purposes and bad purposes. There's normally dual purpose usage for these different devices. So on the topic of artificial intelligence, it is a very, very quick and upcoming field of computer science. It's going to help augment our abilities as human beings. That means we're going to be more capable of doing our jobs better. Of course, there are going to be some jobs that AI, I'm sure, would probably replace. the low-level jobs that are not very, intense as an example. But there is, of course, pros and cons to anything in this world. So these tasks include learning, acquiring information, the rules for using the information, reasoning, using rules to reach appropriate or definite conclusions, problem solving, perception, understanding human language. So they effectively powered by algorithms. You'll see this is from one of the lab tutorials I wrote some time ago, a couple of years ago now, actually showing people the whole Intel Movidius workflow, which really could be more generic as well, but we want to give courtesy to Movidius, who manufactured the hardware device. So the algorithms is at the heart of what we can do with AI. I'm sure many of you have heard, which we can teach the machines. This is the part we call that machine learning. So that means it still needs somebody that knows how to do it, so we can teach it to the machines, or they can even learn on their own with deep learning. So those algorithms process a huge, large amount of data to be able to have obviously number crunch and pattern crunch and make decisions based upon very big data sets. They're learning models. So as you see the typical flow over here, you've got your model, which is where you're going to be doing the training, the machine learning. You've got your profiling, tuning, and compiling, because you wouldn't normally do your training on a Raspberry Pi. You'd need a much bigger computer for that. It depends on obviously what you're going to be training your device to do, but your compiling, of course, is where you normally need a lot more processing power. And then your prototyping, so you'll see you can build a simple language model with objects that will allow you to recognize objects through a camera. So you can take a Raspberry Pi, add a camera to that, and then you can go ahead and identify objects, object recognition as an example. So that would then be finally used. You would plug in your Movidius USB device into a Raspberry Pi, as you can see, or a laptop, and you'll have access to the SDK tools and the application programming interface. Now some of you might be going like, okay, well, I don't have an idea of what I could build. I want to learn AI. Well, I've got to learn AI, I've got to look at some kind of a project. And we're going like, what kind of project could we learn? Well, following today's theme on Wi-Fi, I thought none other than one of my favorite little devices called Pwnagotchi. Yeah, Pwnagotchi. So we're going to be setting up a little Wi-Fi enabled Raspberry Pi Zero. A Raspberry Pi Zero is a small board. It's a computer system. A little bit bigger than your average IoT devices, but you can do a lot of really fantastic things with a Raspberry Pi Zero. So the required hardware is that you have as a minimum a Raspberry Pi Zero. You can pick them up for like $30 nowadays, 35 euros, thereabout. You need to buy a minimum of an 8 gig micro SD card. You can add an e-ink screen, which is obviously optional, as well as a battery for your hardware clock. And this is your e-ink screen, so very low power. And this is your little Pwnagotchi. So Pwnagotchi was built off the premise of the original Tamagotchi project. And Tamagotchi was the digital pet of the 1990s, where you had to look after your pet and feed it. Well, Pwnagotchi gets fed by sniffing EAP-OL, your extensible authentication LAN, over LAN at least packets. You normally have between 1 and 4 when you associate, depending on how and what protocols have been used and what security has been enabled. So essentially making it pretty easy to learn all about AI, because this has only got a 2.4 gigahertz Wi-Fi adapter built in. So the challenge is to take this project and rebuild it. It's all open source, but you're going to then go and train a Raspberry Pi 4, because it needs to be retrained, because its brain only has 2.4 gigahertz. So a Raspberry Pi 4 has 5 gigahertz, And that's the most effective way to get people to start learning AI, by building a project to do something. And that really gets us to think out the box. So let's have a look at their website. I already have a Pwnagotchi set up though. So a few things, you can use DD as an example to go and set up your Pwnagotchi. The website is just Pwnagotchi.ai. And a big shout out to the original developer of this project, Italian guy by the name of Simone. And yeah, done some amazing things, the documentation. What's really amazing, because 1 hour just to let people have free training for an hour at a time, because we know everybody's very busy nowadays. This is going to really help to build your foundational set of, what is AI again? Oh yeah, those algorithms and those fantastic details that the author wrote about how he started this project and the ideas he came about, or how did he come about with some of those ideas. Recommended books that you can use for your AI and your algorithms. So documentation is fantastic. Pwnagotchi is using your reinforced learning, your A2C. So if we just open up, there's a great little tutorial. And again, I'm just sharing these resources with you folks, so you'll be able to go and track after the webinar. So this is your intuitive reinforced learning, an intro to Advantage Actor Critic A2C. We'll go ahead and close it down. And they even give you some really awesome comic strips to really understand AI based upon what Pwnagotchi will be doing. And so in this example, you will actually see your agent, your cranberry fox, in reinforced learning, like you're teaching a dog a new trick as an example. Every time it does the trick, you're going to give it a treat. So in reinforced learning, an agent moves through the states in an environment by taking various actions, trying to maximize rewards along the way. And you can read more about this. So you'll actually see their simple code implementation of the A2C for learning, as well as the industrial strength PyTorch, as well as OpenAI's TensorFlow. You can use some of their original models. And then also Bartow and Sutton's Introduction to Reinforced Learning. You can see there's an entire, I believe that was a course by, British University, UCL. So great write-ups there. And then the Fast AI's awesome course for intuitive and practical coverage of deep learning in general implemented in PyTorch, as well as Arthur Giuliani's tutorial on reinforced learning implemented in TensorFlow. So amazing set of resources. When you go ahead to look at the installation, folks, we're not going to have time to go into the actual setting up and installing everything today. This was an hour almost, where we wanted to give you the foundational things that you're going to need. And then when we see folks again in another 2 weeks' time, we'll be running 2 of these events every month. We really want to give back to society and get them to be up to speed on being able to build artificial intelligence for IoT. Because IoT is so hugely important right now, with a lot of critical infrastructure being targeted. We still have a huge shortage of skilled participants, of skilled people. Now there's a big difference there. There's a lot of people that go on a course and take a certificate, they pass an exam. But let's make it very clear, that doesn't mean to say you have the skills to do the job. Passing a certification exam means they validated you have the theoretical knowledge. So what we're doing here today, folks, is helping you build your skills. I'm not saying the certification courses don't necessarily build your skills. I'm just saying that what we're doing is making sure we're doing it for free without boring you with PowerPoint presentations. We're keeping you interacting by doing it. And so if you look at the instructions, are very, very well articulated in Simone's website. Add in all cool little features. And so once you've set this up, the hardware, you can go and flash the operating system on a micro SD card. So you could download the latest image file there. Very similar to what we did with Arduino, but you would just be using a GUI application like Berliner Etcher as they have in the instructions here. You can also just use DD, doing it manually without having to install software for the most part in a Linux operating system. And then for some of you folks that don't know, you're going to be installing the Raspberry Pi OS, and part of the main architecture of Pwnagotchi is a lot of the networking types of sniffing and reconnaissance techniques, and then essentially being able to launch man-in-the-middle attacks testing your own network. The key point is you need to have approval in your own network by your wife or husband, so they know you're going to be doing these man-in-the-middle attacks. All right? Hey, if not, hey, you're on your own there if your husband or wife or kids get angry with you because you stopping internet access for the whole family. So I'm just giving you the warning. Yes, these are real tools that you can use and learn more about the AI. So as you're walking through this, you will see it will then give you some very, very clear guidance for the configuration. So when you go into the configuration, once you've got the hardware and the software, the operating system set up, then you're going to be able to boot up your device for the very first time. And on the first boot, you will see this is your hardware board of a Raspberry Pi Zero. You need to always make sure you're plugged into the power and the data port, because one of the easiest ways of setting up your Pwnagotchi is when you power it on to the data and the power port, it's going to emulate an Ethernet adapter that will allow you to connect through SSH, your secure shell, where you can actually remotely run your code, your secure shell terminal effectively. And you can see all the details you need, including setting up for Linux and Windows your connectivity. So if you want to SSH to it, you're going to have to set up your networking on your local operating system. And that is it, ladies and gents. So as you've seen, what we covered today was really the fundamentals of IoT first. We showed you how you can set up your basic IoT project. We've given you an introduction to AI, where we're going to be building each session, we're going to be adding on to our foundational toolkits. And you'll actually see I will be taking the group through using AI and a Raspberry Pi with a camera and your Intel neural compute stick. So actually going through building that with everybody so everybody can see how to set up the AI for future use. And with that said, we will stop recording. I want to just thank you all for sharing your time with us today. For us, our time is our most crucial asset, and we are very appreciative that you came to hang out with us and shared your time with us. So thanks so much. We are going to be breaking it out into QA right now.